Maybe you know. Science meets the questions you never thought to ask. It's 2 a.m. in August 1977. A teletype printer chatters in an empty Ohio control room. No one is watching. A few days later, a 32-year-old astronomer named Jerry Emin lays the printouts across his kitchen table, scanning columns of numbers between bites of dinner. His pen stops. 6 characters, stronger than anything anyone has ever recorded from the sky. He circles them. He writes one word in red ink. Wow, he doesn't sleep that night. 47 years later, no one has heard it again. In 1977, the Ohio State University Radio Observatory was a strange piece of metal in a field. Locals called it Big Ear. It was bigger than 3 football fields, lying flat against the earth like a mirror tipped to the sky. No spinning disc, no domed antena. Just a 340-foot reflector designed by an engineer named John Krause to scan a sliver of the heavens as the planet rotated underneath it. By the 70s, Krause had handed the search over to a quiet astronomer named Robert Dixon, who pointed Big Ear at one specific frequency, 1,420 megahertz, the hum of neutral hydrogen. It's the most common note in the universe. Every star, every nebula, every empty stretch of space whispers in it, which is exactly why scientists thought any civilization trying to be heard would broadcast on that frequency. A cosmic dial tone. Big Ear was tuned to it 24 hours a day, 600 sweeps a year. Mostly noise, sometimes a satellite. Once in a while, a strange wobble that turned out to be a microwave oven on Earth. And then came August 15th. Jerry Emin wasn't even at the telescope that night. He was a part-time professor, an unpaid volunteer, who reviewed the printouts at home when his teaching schedule allowed. The signal arrived on August 15th, 1977, at 10:16 p.m. Eastern Time. For 72 seconds, Big Ear's antenna pointed at a tiny patch of sky in the constellation Sagittarius and recorded something it had never seen before. Then the Earth rotated, the antenna drifted off target, and the signal was gone. The teletype kept printing through the rest of the night. Days later, Emin picked up the stack at his kitchen table, a fork in one hand, a pencil in the other. Each column showed signal strength as a single character. Mostly 1s and 2s and dashes. Background hiss. Then 6 characters jumped off the page. 6 EQUJ5. He set down his fork. He grabbed a red pen. He drew a circle around them, wrote wound next to them in the margin, and flipped back to the columns before. And after, nothing. The strongest narrowband signal SETI had ever recorded had lasted exactly 1 telescope pass. To understand why 6 characters froze a man over his dinner, you have to understand what those characters meant. Big Ear measured signal strength on a single-digit scale, 0 through 9, then jumping to letters, A, B, C, to fit higher numbers into one column. U was the 30th step, roughly 30 standard deviations above the background noise. To put that in perspective, imagine you're at a quiet beach. The waves are background noise. A normal SETI ping would be a fish jumping. The wow signal was a freight train passing through your living room. It was narrowband, less than 10 kilohertz wide. Almost no natural object in the universe broadcasts that cleanly. Stars roar across the spectrum. Galaxies hum in chords. A laser-thin signal at one specific frequency is the radio equivalent of a perfectly tuned violin string ringing in an empty cathedral. The signature of something built, not something burning. And the frequency? 1,420.4556 megahertz. The hydrogen line. The exact note Frank Drake had told the world to listen for in 1960. The precise dial tone of the cosmos. Big Ear was tuned to it. And someone, or something, answered. Then Emin did the obvious thing. He waited. The Earth would carry Big Ear past that same patch of Sagittarius again the next night, and the night after, and every night for years. He scanned it more than 50 times. Nothing. In 1987, an astronomer named Robert Gray pointed an even bigger telescope, the Meta project at Harvard, at the same coordinates. Silence. In 1995, Gray rented time on the Very Large Array in New Mexico, 27 dishes working as one. The most sensitive radio instrument on Earth. He stared at that patch of sky for hours. Hours. The cosmos gave him nothing. In 1996, Big Ear itself swept the area for 14 more passes. Empty. In 1999, the telescope was demolished to make room for a golf course. The metal that had heard the loudest narrowband signal in SETI history was scrapped. And the strange thing, the thing that ate at Emin for the rest of his career, was that all the noise it should have caught was right there in the sky. Stars, pulsars, microwaves, everything except whatever sang at 10:16 p.m. on August 15th. For 40 years, every explanation collapsed. A satellite reflecting a ground signal? The frequency was protected. International law forbade transmissions on 1420 MHz. A military test? Records cleared. A glitch? The signal showed the exact rise and fall pattern an antenna would record as it drifted across a real point in space. Then in 2017, an astronomer named Antonio Paris at St. Petersburg College in Florida proposed a new culprit. Two comets, 266P/Christensen and P/2008 Y2 Gibbs. He had calculated that both had been near the WOW coordinates in 1977. Comets, he argued, are surrounded by clouds of hydrogen, and a dense enough cloud could ring at 1420 MHz. He got headlines. Wow, signal solved, until other astronomers actually checked. Hydrogen clouds around comets are diffuse, thousands of times too weak to produce a 30 sigma signal. The comets weren't even at those exact coordinates within Big Ear's field. Robert Dixon, still alive, called the paper unsupported. The journal that published it quietly distanced itself. The signal stayed unexplained. And then, 3 years later, a Spanish astronomer in lockdown decided to look in a different direction entirely. His name is Alberto Caballero. In May 2020, while Madrid was under pandemic lockdown, he downloaded the publicly released catalog from the Gaia Space Telescope, a database of nearly 2 billion stars. He cross-referenced it against the precise coordinates of the WOW signal, narrowed by Big Ear's antenna pattern. Out of all the dim, distant points in that patch of Sagittarius, one star stopped him. Its name is 2MASS 192819822-2640123, a Sun-like G-type star, almost identical to ours in temperature, in mass, in age, roughly 1,800 light-years from Earth, which means if anything had transmitted from a planet around it, the signal would have left in the year 177, when the Roman Empire was at its peak, and arrived in Ohio in 1977 to be circled by a man with a red pen. Caballero was careful. He did not say it was alien. He said, this is the most likely candidate, if it was. And here is the unsettling math. Big Ear's antenna pattern covered an area of sky containing thousands of stars. Out of all of them, only one was a near twin of our sun. And it sat exactly where the signal came from. Right now, telescopes you have never heard of are still listening. The Breakthrough Listen project, funded with $100 million by Yuri Milner in 2015, points the Green Bank Telescope in West Virginia and the Parkes Observatory in Australia at suspicious patches of sky. The WOW coordinates are on their list. So far, nothing. The Allen Telescope Array in California stares at it for hours every month. Nothing. Modern receivers are 100 times more sensitive than Big Ear was. They could pick up a cell phone call from Saturn. And yet, that one specific patch, 1,800 light-years toward Sagittarius, has stayed silent for 47 years, which leaves 3 possibilities. The signal was natural, and we don't yet understand the physics. The signal was a one-time engineering accident on Earth that perfectly mimicked an interstellar source. Or somewhere out there, something turned a transmitter on for 72 seconds, then turned it off forever. Maybe it was a beacon meant to be heard once and never repeated. Maybe whoever sent it is gone. Maybe they sent thousands of bursts and we caught a single grain of sand from a beach we cannot see. Jerry Emin is in his 80s now. 47 years after the night his pen stopped, he has spent more of his life thinking about those 6 characters than any other 6 characters in the world. He has never claimed they came from aliens. He has never claimed they didn't. In one of his interviews, he said only this. It was the strongest signal we ever saw, and it never came back. The printout, that real piece of paper with a real circle of red ink and a real word written in the margin, sits in an archive at Ohio History Connection. Most people never request to see it. Big Ear's gone. The golf course that replaced it is largely abandoned now, the field grown wild. And somewhere above that quiet patch of Ohio sky, in the direction of Sagittarius, there's a star that we now know exists. And it is silent. In 1977, the same year Big Ear caught those 6 characters, NASA launched 2 probes carrying a golden record into the cosmos. A message we sent out, hoping someone would listen. They are now over 15 billion miles from Earth, still broadcasting. Next time, the strange story of what is actually on that record, and the part Carl Sagan refused to remove. Subscribe so you don't miss it. Thanks for watching. If this sparked a question, drop it in the comments. It might be our next video. We'll see you next time.